In Lesson 1-3, we're going to be discussing algebraic expressions. Our objectives for the lesson are to evaluate algebraic expressions and to be able to simplify algebraic expressions by looking at some new properties that we're going to discuss. All right, let's look at some common terminology that we might use to let us know that we're performing a specific operation. So let's first of all begin with the operation of addition. In addition, you might see the words plus used, sum, more than, increase by. If we're looking at subtraction, of course you might see the term minus. You could see the word difference, which we know is the answer to a subtraction problem. We might see the word less than, decreased by. Multiplication, some common terms that you see there would be times, product, twice, where we're multiplying by 2, triple. A lot of times if you're reading a word problem and you see the word of, that means to multiply. Not all the time, but that's a common term that we might use for multiplication. If we're looking at division, you might see the word quotient, ratio, you might see half, where we're dividing by 2 or multiplying by half. These are all common terms that we would use to help us read through a problem and decide what operation we need to perform to maybe solve that problem. Now let's take a moment and look at the order of operations. As we're looking at simplifying our expressions, we need to know what order we perform our operations. A common acronym that we use for the order of operations is please excuse my dear Aunt Sally. So you've probably heard of this even since elementary school, but I want to make sure I just point out a few things about this. When you are looking at the acronym, the please, remember, stands for parentheses. Now that could be parentheses or brackets. It's any kind of grouping symbols. Excuse is exponents. So that's where you're going to look for your power, squaring something or cubing something. This is the part that's really important. My dear stands for multiplication and or division, but it's really important that you understand that that is done in order from left to right. So if a division problem comes first, you do it first, and you do the multiplication later. Same thing with addition and subtraction. It's not always addition first. It's done in order from left to right, and so if a subtraction problem comes before an addition problem, you do the subtraction problem first. Addition and subtraction have the same order of importance, just like multiplication and division. Now let's take a moment and use the order of operations to evaluate some expressions with the values of A being 3, B is -2, and C is 6. So we'll take our first expression and replace all the variables with their values. So that's going to give me 4 times 3 plus 6 divided by -2. Well, parentheses first. Inside the parentheses, we have multiplication. So 4 times 3 would be 12 plus 6 divided by -2 would be 12 plus 6, because that's in parentheses and is an operation. So that would be 18 divided by -2, which would be -9. In our next problem, we're going to do a squared divided by bc. So a squared would be 3 squared divided by b, which is -2, times c, which is 6. So using order of operations, we do our exponents first. 3 squared is 9, divided by -2 times 6. Now we do the division because it's the next operation. We have division and multiplication, but left to right, the division is first. So 9 divided by -2 would be -4.5, which we don't really like to work with decimals, so we're going to leave that as a fraction. We'll leave it as an improper fraction of -9/2, and then we want to multiply that by 6/1. Now remember that to multiply fractions, you multiply numerators and then multiply denominators. Well, that gives me -54/2, which simplifies to -27. A shortcut that we could have used on that was, remember also that we can simplify when we're multiplying. The 2 and the 6 are both divisible by 2, and that would give me 1 and 3. And now I can multiply numerators and denominators, and I would get -27/1, which is -27. Then our last problem, we're going to do -b³, so that's going to be negative, and b is -2³ plus 4 times c, so 4 times 6, minus a, 3 minus 2 times b. Again, we're going to use order of operations, so we're going to start by simplifying inside my parentheses. So this is going to give me negative, and then -2³ would be -8, plus 4 times 6, minus 3, and then minus 2 times -2 would be -4. But remember, minus means add the opposite, so I can quickly change this to plus, and then +4. So now I can go ahead, following with the order of operations. I would do my multiplication. I can go ahead and actually do the negative of -8 and get +8, plus 4 times 6 is 24, minus 3 plus 4 would be 7. And now doing my operations from left to right, I have an addition. 8 plus 24 would be 32, and 32 minus 7 would be 25. Now, I do want to point out that I did combine some steps there, and I don't care if you do that like I did, but you need to be very careful. If you're not sure whether you can do a step in a particular order, then do one step at a time, take a few more steps and get the problem right, rather than trying to rush and use shortcuts and get the problem wrong. So before we move on and look at some properties for simplifying algebraic expressions, we need to look at some vocabulary. So we're not going to discuss what does it mean when I talk about a term, because we're going to be combining terms. So a term is just an expression that can be made up of a number. It could be made up of a variable. It could be a number and a variable, or more than one variable. So it could be like a number times a variable. So a term could be 5. A variable would be like z. A number and a variable might be like 2x, or we could even have like 2xy. Now, a coefficient is the number or the numerical part or factor of a term. So if you have like 3x, then 3 is your coefficient. So the easiest way to remember coefficient is just the number in front of a variable. A constant term is just a number, so it has no variables. So 4 is a constant. And then like terms have the same variables and the same powers on those variables. So you might talk about 3x and 5x are like terms, but 4x squared and 7x cubed are not. Because even though they both have the variable of x, the exponents are different, and so they can't be like terms. Now we're going to finish up with a few properties that we're going to use to simplify algebraic expressions. These are all things that you should be familiar with, but we're going to use them, and you probably already use them and don't even think about it. So let's look at what do we mean by the definition of subtraction. So in subtraction, we really mean that if you want to do A minus B, that's the same thing as A plus negative B, or the opposite of B. A lot of times you're going to hear me say, change your subtraction problems to plus the opposite. Division, what does it mean? Well, if I have A divided by B, first of all, we need to realize that that can be written as a fraction. Fractions are division problems. But A divided by B is the same thing as A times 1 over B, as long as we specify that B could never equal 0. The distributive property for subtraction is just like the distributive property for addition, except inside your parentheses you have a subtraction problem. So if you have A times B minus C, you get A times B minus A times C. Multiplication by 0 is just as simple as it sounds. If you take 0 times anything, you're going to get 0. Multiplication by -1 says if you take -1 times anything, you're going to get the opposite of that. So -1 times A would be -A, which is just the opposite of A. The opposite of a sum. So if I have the opposite of A plus B, that means you're just going to do the opposite of both of those. That would be -A plus -B, which we could also write as -A minus B using our definition of subtraction. The opposite of a difference. If you have the negative of A minus B, that's -A plus B, which is also the same thing as B minus A. Notice that the B is positive in both of these last two answers, and the A was negative. The opposite of a product. If you have negative A times B, we actually miss this a lot in mathematics. This is -A times B, A times -B, but you don't multiply both of those or make both of those negatives, because remember that if I did that, that would actually change the problem to be positive. You're not distributing that negative through to both of those. Then the opposite of an opposite, if you have the opposite of -A, we should understand just numerically, if we take the opposite of a negative number, we would get a positive number, and so we would just get A. Now we're going to use our properties to combine like terms and simplify expressions. So you already do this without knowing the property name that you're using, and I don't expect you to know the property, but I do expect you to understand how to use those properties. So let's first of all discuss which ones of these are like terms. Remember that like terms have to have the same variables and the same exponents. So a 7x squared is only a like term with another 7x or with another x squared. The coefficient can be different, but the exponent has to be the same. A 3y squared would be a like term with another y squared. Now if I combine those, 7x squared and -4x squared would give me 3x squared, and 3y squared plus 2y squared would give me 5y squared. In our next problem, notice that we can use the opposite of a difference here at the beginning, and let's make this -3a plus 5b plus, and now we'll do distributive property, 4a minus 8b. And now again, let's find our like terms. So our like terms would be -3a and positive 4a, and then we also have like terms of 5b and -8b. So if I combine those, let's combine our a's first. -3a and positive 4a would just be 1a, or a. Positive 5b and -8b would be -3b. One last problem. Let's use our distributive property, or do the opposite here of a sum and difference problem. We'll distribute that negative through. -6x cubed minus 5x plus 7x squared. Now, changing the signs of everything inside the parentheses, because we can think of subtraction as plus the opposite. So this would be plus, and then the opposite of everything in the parentheses. -3x, negative 5, positive 2x cubed. So let's look for our like terms. So we have a 6x cubed, a 2x cubed, so there's a like term of x cubes. We have a negative 5x, a positive, that's not a like term, I've messed up there. That actually should have been an x squared, so let's fix that. So that's 7x squared. So our like terms then would be 5x and negative 3x. Okay, there's no like terms with the x squareds. And then we also have a constant out there by itself. So it has no other like terms with it. So looking through, and I'm going to put these in decreasing order. So our highest power was an x cubed problem. We had 6x cubed, 2x cubed, or negative 6x cubed, positive 2x cubed, so that's negative 4x cubed. And a lot of times when I have multiple terms, I will mark those out to let me know I've used those. Now my next term would be an x squared. Well, we didn't have any like terms with it, so we'll just bring down the plus 7x squared. Then my x's, negative 5x and negative 3x, would be negative 8x. And then the last thing was my constant of negative 5.